Hey math kids, today we're going to talk about some other triangle theorems. So we're going to start with this one called the Sidesplitting Theorem, and I need to fix this. Okay. So what the Sidesplitting Theorem says, that's still too big. There we go. So let me just write this. We have AE over EC. This is side splitting theorem. And the figure that goes along with this is we have a triangle. We'll call this A, B, C. And then we do parallel piece right here. We're going to call this D, E. And once we have this, we set up some proportions. So we're saying AD and DB are in proportion the same way that AE and EC are. Okay? So in other words, if we take AD and we divide it by DB, and then we take AE and divide it by EC, we'll get the same number. Okay? So let's look at one of these problems. So let's see. I'll need to draw a different diagram. So if I have this situation, and we're going to call this AD. Let's see, A, B, C, D, E, F. Then up here's G. And if we are given AB over BC, we want to know how that compares to DE. So if we're using the side-splitting theorem, we look at AB, and then we look at BC, and we look at DE, and so the missing piece right there would be EF. Okay, let's look at one more of those. So if we're saying AC over DF, then we have AB, and we want to know this one. So this time we have AC, so it's the entire thing. Then we have DF, okay. And then if we have let's see, AB, which one's going to correspond to AB? Well, that's going to be DE. Okay, so you really just kind of look around and see which piece would correspond to the other piece with the side-splitting theorem. Okay, now the next one is the angle bisector theorem. And to talk about this one, we have a triangle that looks like this, and then we bisect this top angle. So sometimes they write that as alpha alpha, whatever you want to call it though. A, B, C, and then this is D. And if that's true, then we get AB over BC equals AD over DC. So we look at AB, we look at BC. So in other words, we look at those two outside ones with relation to this, and then the side that's split. Okay, so AB, BC, and then AD is this little piece, and then DC is this little piece. Okay, so let's try a problem related to that one. So we're given this. We're told that it splits. We have A, B, C, D. This is the split angle right there. We're told that this is 3.5. We're told that this is 5. This is X, and this is 12. So we want to find X. And so we're going to do a ratio of the outside sides, so the 12 and the 5. And then, because we put 12 on top, it actually doesn't matter which one goes on top or bottom. But since we put 12 on top, we're going to put X on top because it's, adjacent piece to the 12. Right here, AB and AD are adjacent pieces right there. And then on the bottom goes 3.5. And so we just do a little bit of algebra, multiply both sides by 3.5. 3.5, let's cancel, and so X is equal to, pull open my calculator, so we're going to say 3.5 times 12 divided by 5, we get 8.4, and that's all we have to do on that one. Okay, actually think that's everything we need. Yep. So if you need additional help, please come to Math Lab. Until then, calculator.